Hey everybody, we are going to walk you through how to program the MOREbot, and let's just jump right into it. So to start, I have a new Arduino sketch here. I'm going to assume you've already opened up Arduino and configured everything like you need. What you need to do next is go to File, then go to Save As. I'm going to call this my robot. Hit save. Now we're good. So in order to program and control our MOREbot, we need to include a library. And a library is basically a set of commands that we made so that the MOREbot understands what you want it to do. So instead of typing very specific things like what each pin should do, you could just tell the robot to go straight and it will. And so I'm going to show you how to do that. So the first thing we need to do is include that library that we had created. So we're going to do hashtag include open MOREbot library.h. So the reason why it's a .h is a type of file, and that file links to several other files that explain to the robot what to do. So you don't really have to understand that to be able to use it, just as long as you have this statement right here at the beginning. So now what we need to do is include the thing that will let us control the robot. So this is a library and it gives us access to all the functions. Now we need to actually use them. So we're going to create what's called a drive controller, what we named a drive controller. And this is what's called an object. And an object in programming is kind of like a variable. So remember how I could say int j equals 10, and then I can say int I equals 11, and I can say int y equals I plus j. Well, that's because a variable is kind of like a really simplified object, right? I can do operations with it, and it's storing some kind of memory. Just think of an object like a variable, but you can do more with it. So the first thing we need to do is tell it what type of variable it is. So we say drive controller, and I'm going to call this controller robot. And next we need to say what it is. Remember how we would say int I equals 10? That equal sign is where we are assigning 10 to I. So in the computer, in the brain's memory, it knows that I is equal to 10. So we're going to be doing that same thing right here with our robot. So what we need to do is say robot is equal to drive controller. If we're using the breadboard, which all of you should be at the time of this video, you go 3, 4, 5, 6, 7, 8. So why do we do that? Well, short answer is it's not really worth getting into. Long answer is that's calling a function inside of our library that's creating this robot, and these numbers are things that robot needs to know in order to drive. So we don't really have to know what they are. You don't right now. In the future we can explain that, but just make sure that you have that. So after we do that, we need to do something else to get that robot ready. Do you remember when we wanted to print something? I would do serial.begin 9600, and then down here I could say something like serial.println hello. Well, in order to print down here, I had to set up the code right here. I had to initialize it. And so we're going to do exactly that for our robot. What we're going to do is type robot.setup. And then now we are ready to control our robot. So the way that we're going to do that is we can control each motor in our loop. So remember, actually we'll do the loop afterwards. Right now let's do the setup. So remember that the computer, the robot, looks at this program and it treats every line as a new instruction what to do, because computers are really, really dumb, and so you have to tell them very, very plainly and in a way that they can understand what to do. And that's why it goes line by line. So in this setup, between this bracket and this bracket, it's going to run through these instructions once, and in this loop it's just going to keep running it repeatedly. So we just wanted to do things once. And what we're going to do is say robot.motor1, we want it to go some speed. We'll call it 100. So the way that this function works, remember that 2 slashes is a comment, so the computer is going to ignore this line that I'm typing now. We say robot.motor1, and then we put some speed in here. And speed is some number, integer, meaning it can't be 1.0, it's got to be 1 through 100. So it can't be, 100.25 or 0.34, right? It's got to be just 100 or just 1. So I'm going to say robot motor 1 is going to go at speed 100. And we can actually upload and test this on our robot. And I'm not actually going to go through that right now. I'm just going to keep moving, but you should go ahead and pause right now and upload it. So one thing you might notice is it doesn't actually do much, right? And the reason is that call, that instruction, lasts a really short amount of time. So what we need to do is to tell it to keep running that instruction. And the way that we're going to do that is write delay some number in here. So what delay is doing is it's basically saying, hey, don't do anything else. Just keep doing what's up there. Just keep running that. And in this instance, we want it to do that for 1 second. So inside of the delay is milliseconds. So 1,000 is 1 second, 2,000 is 2 seconds. You get the point. After that, I want to say robot.motor1 0. And then any guesses as to what this does? I'll spoil the surprise. Basically, it's turning off that motor. So you might have guessed it by now. You can do the same thing for the other motor, because there's 2 motors in the robot. So we can do that, and that's going to make the robot go forward at full speed for 1 second. And then we can say robot motor 1 0, robot motor dot motor 2 0, and our robot's going to stop. And you can play around with these values. So if I change this to 50, if the motor 1 is on the left and the motor 2 is on the right, this thing will turn to the right because the left side is going faster than the right side. And you can take some time to play around with that. One thing to remember, you need to include these semicolons at the end of your lines. That's just telling the program that, hey, I'm at the end of this instruction. So that's why I'm always putting it there. And if you want to play around with it too, you can also take these, right-click, left-click on copy, come down here, right-click, left-click on paste. And then I can come over here and delete that. So now, the computer, the robot, is going to run this continuously. So it'll turn right, and then stop, and then immediately turn right. And so if we want it to stop for any kind of meaningful time, we would say delay 1,000 again, so it would turn right, then stop, and turn right, and stop, and eventually kind of make a big circle or square. So, if I wanted to go forward, it's kind of annoying to have to type in motor 1 and motor 2 if I'm just wanting it to do one thing. So we created some programs, some functions that will make that easier. So if I wanted to go straight, like I'm doing right here, I'm just going to erase all of this. If I wanted the robot to go forward, I would tell it to do that. So I would just say robot.forward, and then whatever speed I wanted it to be. So speed can be anything from 1 to 100. So I'm going to say go forward 100. I'm going to say delay 10. And what this delay is doing is basically making sure a loop doesn't run too fast. And it's really not worth going into all the details of that, but just know that it sometimes helps to put that at the end of our loop. So we can just put that to the side and ignore it, because once you do this and compile it and run it on your robot, it will just go straight. It'll take a little while to compile. Anyways, and it's not compiling because I don't have the board plugged in, but you can just ignore that. Yeah, anyways, so robot.forward will make it go straight, and you can probably guess what the other functions do. We also have robot.backward at whatever speed. I'm going to call it speed just up here, remember that speed is some integer, which stands for number, between 1 and 100. In fact, we could even make an integer called speed. So we could say int speed is equal to 100. Actually, I think it doesn't like that. That's why I was highlighting in red. Probably because we use it elsewhere. But anyways, you can also do robot.left 100. You can also do robot.right 100, or you could do 75, or you could do any number. And so those are the four commands: straight, left, right, back. Now, if I wanted to make something more with that, make it go into like shapes, for example, I could use the delays. So if I wanted it to go forward, if I wanted to make a rectangle or a square, right, I could go robot.forward 100. I can tell it to go forward for 1 second, and then I could say robot.right for 50% speed, delay 500, and these are just random numbers, and I'm not testing them. What you'll need to do is test that. So that's not necessarily going to make a 90-degree turn. It could turn 360 degrees, or it could turn only a few degrees. You have to test it and tune that number and that number to get it how you like it. Anyways, I would just continue to do this 4 times. So the first time I'm going to go straight, right? If my little cursor's the robot, I go straight, turn right, then I go straight, turn right, go straight, turn right, go straight, and then I turn right again. So I should be facing that way. So you can try that code, see how it works for you. I'm betting it probably won't work the first time. You need to change some numbers in here. And in the next lesson, we'll get into loops and a way to make this a lot easier. Anyways, I hope this was easy enough for you to understand. I know I went kind of quickly through things, so feel free to go to our website, which is www.moretech.co, and you can ask us questions directly on there. Anyways, best of luck and see you in the next video.